All right. I want to welcome everybody to this January meeting of the Homebrew Robotics Club, first meeting of 2026. I think it's going to be a heck of a year for robotics, and we'll see. We're all part of it. The order of events. What we do here is we'll start off with industry news, and then we'll do club news and what I need help with. We'll have show and tell, and then the presentation. And random access is where we hang out till the security guards come and throw us out. Okay, and so let's go ahead and get this thing started with industry news. Does anyone have industry news that they want to talk about or mention?
Well, I did go to CES and saw lots of cool robots there.
Nice.
With them boxing passerbys, and really, they have some really amazing demos with full, like torso up robots making a pinwheel and playing cards and doing a bunch of different things. And
Stephen, who's doing this?
I'll have to pull up the pictures. It was one of the, I think that was a Chinese company. Yeah, it might. I think it was Sherpa. Yeah. There were quite a few companies, and then there was a pretty big booth for the Korean companies that had this big board that was explaining about the Korea-wide humanoid robotic ecosystem that they're putting together. A whole bunch of different companies, and then they had a number of them there. Different companies making different.
Was this a trade show or something you're talking about?
Consumer electronics show.
CES. Oh, wow. Okay. I'm jealous. I've always wanted to go to CES. I've never gone to CES.
Just a little show. Just a little.
Well, the audio, folks. The audio through this is not good at all. So when you talk very slow and deliberate. Okay.
Okay. I will try, but so yeah, it was interesting. I think I saw there was something like 140,000 people went, some crazy number. I actually kept walking back and forth past the whatever the Robo Arena thing was, but I didn't get a chance to go. So, but I think they just had to talk about there.
Outside with this?
Yeah, is this better?
Yeah. That's better.
Oh, okay. So maybe it's that particular
That's
microphone.
dramatically better. Thank you. Thank you.
Oh, okay. Okay. So I'll eventually get my pictures together and post. So there was quite a bit of robotics and a lot of pretty smooth movement and a lot of remote control, a little bit of automation. So it was pretty good.
Well, who is it? The robot? It's Ecovacs or somebody. Haven't they put an arm on their robot vacuum cleaner?
Yeah. There was a company that was doing that 6 months ago or something, a while ago. Yeah, I didn't see them there, but so it's on the robot vacuum. The idea is that it'll pick up socks or things that are in the way of the vacuum. That's sort of the vague idea, I guess. But I did ask that company. I think
they had it putting away toys too.
Yeah. So I did talk to the company that had all the robot demos, and I asked them, a little bit about their hand, and it's using the camera in the fingertip touch sensing, which is very sensitive but also expensive. And the guy told me that each hand cost $50,000. So actually, but probably the thing I was most excited about is I went to the Bosch booth, and they were only showing a few items, but it happened to be 2 or 3 sensors that are perfect for robotics. and they had a demo hand with 3 of these sensors in each fingertip, demoing that it could detect a feather brushed against the end of the fingertip.
Oh, wow.
So that's pretty exciting.
Who is this?
Bosch. Bosch with a B.
That's the German tool company, right?
Correct. Yep. They actually have a fab in California now. It's doing, I think it's doing MOSFETs.
We have a bunch of experts throughout. We recommend that robotics and personal.
Let's see. I got a few things here.
Okay.
Must be attended at all times. Do not
See, I'm going to put this in the chat. The robot report's a great source for industry news.
with TSA regulations.
And a couple of things I got from that is Gartner predicts fewer than 20 companies will deploy robots by 2028. I'll put that article in the chat there. Some of it says the market research firm doesn't expect this to change anytime soon. It says that there will be fewer than 100 companies progressed with humanoid proofs of concept beyond experimentation, even though close to it exists today. One of the points they make is polyfunctional robots will dominate the warehouses, Gartner. Mobile manipulators with wheels and telescopic arms can move boxes, pick cases, scan inventory, and perform inspection with higher uptime and using less energy than a humanoid that is attempting to do the same task. So I'll put the link in the chat for that Gartner story. Also, there's a new robot called Sprout. Have folks heard about it? I'll put a link in the chat. This is a company called Fauna, and they say that's a blend of approachable materials. People say my robots are approachable. You know what that means? People look and say, I can do better than that. I say, come on in, the water's fine. But anyways, they have approachable materials, personalized aesthetics.
Oh,
They
yeah,
want to make
sweet.
a versatile platform for education, therapy, and interactive research. And he talks about the early days of personal computing. And I think we all feel the same way as the hobbyists and the enthusiasts that are going to drive this thing forward. Let me share some of the screen, just kind of share it here. Sharing not turned on. Let me turn on sharing. Hey, Thomas, can you turn on sharing? Sharing.
Give me a second.
Seconds over.
Yeah, hold on, hold your horses. Moving a little slower. Okay, try it now.
Technology is great when it works. Let's see here. All right, bear with me. That's not what I'm going to do. I'm going to go back to the application. There's the, get me started. Okay. So here's the Sprout.
We don't see anything, Camp. We just see an empty screen that says host has started. Oh, there it is. Now we're getting it. Just it was a little delayed.
Be patient, Thomas. Be patient.
I know you're on a phone.
I'm on a phone hotspot in the airport.
I know.
Patience is a virtue. 2, 3, 4. Okay, it doesn't seem to be coming up, but anyways, I put the link in the chat for the Sprout robots. You might want to check it out. I looked around a bit to try and find a price on it. They say it's $50K, but that's cheap for a humanoid robot. Actually, the Unitree, well, that's cheap for an autonomous. The Sprout has the Sprout has the
Not transport any items for someone you do not know.
it's got the NVIDIA Jetson AGX Orin at 64K in it, so that's probably an expensive board right there. My screen is coming up here, so this is the Sprout. It'd come up a second on Zoom, I'm sure. Bear with us.
Papers, painting, fall, water. Go to the thermal tubes and programs to plan one.
Little light green. Oh, here we go.
Let's just get a little taste of it here.
We're not gonna see it through your connection cam.
You want?
I'm sorry, what?
Do you want one of us to play it?
Meals the
It's coming.
including but not limited to diet, both board, covered board, and real wood.
If I do another one, I'll take advantage of that, okay?
Hey, Cam, if you want me to run it, I can do that for you. It's running real slow and real low res.
The robot walks slowly, and it is a low res robot. But this is Sprout. This is Sprout, okay? You can get one of these. They say they're on sale as of yesterday for $50K. So there you go.
But what do they do?
Looks like a toy.
Yeah.
It holds your stickers.
Yeah.
They specifically said that they're setting it up for research labs and things like that. Why
they
you
also
want
talk
a
about-
friendly one, I don't know, but
Well, they talk about the home, and they talked about it was kind of funny. I read article I read. They were talking about hotels, and in particular, it delivering toothbrushes for some reason. But anyways, there's that. Okay, let's move on. Let's
So
see.
the
We're still-
the what is it? The Wuji hand?
Is that what's the question?
Do you guys see the Wuji hand?
Are you sharing your screen?
I will share it here in a second. So here, let me bring it up. And then I can go here and share this. So this is
You have a worm gear here, and then you have the.
so this is a new hand that was announced, and
all the frames here you can see are the different degrees of freedom. So
it has.
you can go ahead and actuate it here.
See if I can get a better view. This is their model of it.
Really couple the video.
So this
nice.
hand basically has a bunch of embedded motors. It's from a company that makes miniature embedded motors. And
this 4-bar linkage here. So this is how it does, which I'll show you
And
in
it-
a little bit.
what's nice about it is it has, I think, 22 degrees of freedom, 20 or 22 degrees of freedom.
Blown up.
And like it actually has more for the joints that it's covering for the fingers. It has more degrees of freedom than a human hand does,
Wow.
because our smaller finger, some of our joints are coupled, right, with tendons,
One level here.
and they have independent control of every joint, and they also can do the splay individually of each finger. So the clever thing that it looks well, and so one of the things they show is you can grip something heavy and then lift it up, and people are trying to discern exactly what the mechanism is in this, and the best conclusion I've seen is that it's basically they basically have a gear motor for each joint of the finger. And the best guess is, I think, is that they're doing a worm gear on right at the joint. So basically, the backside of the center post is likely has a worm gear
I'll
surface.
bet it's got a hell of a grip.
Yeah. So with the worm gear. Well, so that's the thing. I don't think it's necessarily. They talk about it's relatively strong, but it's really strong once it has gripped something, right? So because it's using worm gears, so that doesn't necessarily mean that those fingers are strong enough to do that grip. But if you were to, I think it's a different video where they're showing like gripping a weight and then picking it up. So wrapping the fingers around it, they probably don't have a whole lot of strength, but once those fingers are in position, then you can lift it up because those worm gears are going to lock it in. So I have a completely different mechanism. So like a tendon-based mechanism that is what I'm really interested in right now in humanoid hands. But I'm kind of tempted to try to build a cheapy version of this design.
Can you put that link in the chat,
Yeah,
Stephen?
thought I did, but maybe not.
Maybe you
Oh
did.
no, I just shared so far. Yeah. All right. Yeah. As soon as I stop sharing, I will put that in there.
Luggage and parcels must be attended at all times. Do not leave your luggage and parcels unattended as they may be removed in accordance with TSA regulations.
Any other industry news? Let's move into club news now. Any club news that we've got? Let's see now. It's January. Anything coming up? Marco?
Lost by the base tomorrow night.
Say the monthly Ross by the Bay is tomorrow night for anybody that also wants to go to that.
Go to Ross by the Bay. We need to infiltrate that group. I want a homebrew presence.
I went
at Ross
once, and
by
it's all the
Bay.
people that used to come regularly here.
Well, they've got our spot at Google. I remember when we were at Google. Those
Okay.
days are gone. But anyways, we can sneak back in there. So go to Ross by the Bay. When is it, Nathan?
Tomorrow night at the
Tomorrow
Google
night.
facility.
More robot stuff. Did they do that? Did they do a did they do
Free
it
pizza
virtual
and beer, by the
also?
way.
Hey, Cam, you know, you're still sharing that video.
I found the
That's Steven.
I found the official video.
Mm.
It's a nice hand.
Yeah, I
50
think
grand, it better be
saw,
a nice hand.
I think I saw that they're quoting $5,500 for it.
5,500.
Which-
Oh, wow, that's a lot better. I thought you said
A lot better.
50,000.
One less zero.
Yeah,
Yeah,
5,500. Okay. That's reasonable. For 10K, you could have two hands.
so people aren't clear if they're doing touch sensing and how. Some people are theorizing that it might have the touch sensors in the glove.
I mean, if you put touch sensors in there, then prices are too cheap for that.
Well, it depends on what you use, because I like using these new sensors that Bosch has. You could easily have a bunch of them. I think I'm trying to remember the price. Forget. I have to look it up. They're less. They're $5 or less. They're either. I have to look up now. So it's a pretty nice hand.
No, remember when was it Tony Canis did his summer internship where he had the PR2 fetch coffee for the professor. There was a whole back and forth where the robot had to understand how to hand the cashier the money, and when the cashier properly had the money, then the robot would let go of it. But it was, you don't think about that stuff, but it's the whole deal. Wow. Wow.
Extreme test. Do not imitate. Especially if you go 5,500, not covered by warranty.
At any time. Do not transport any item for someone you do not know.
They're cheating. The hand was closed anytime they hit it.
Or considering or approaching you about carrying any object, contact the airline representative or an airport immediately. All that can carry on luggage is subject to
So if you look at this, because I kind of looked at it a lot, there's one motor here controlling this joint. There's one motor here controlling this joint. I don't know, can you see my? And then there's a motor here controlling this joint. So this segment is unnaturally long because it has two motors in it. And then there's a motor here that's controlling the side to side joint. So they have it's an interesting. Oh no, I might have that wrong. This one here, I think, is controlling side to side. I know they did something where they reversed those. And all the fingers are the same length, but they start at a different place.
It's 50,000 per year.
Very cool.
No, this one is 5,500. That other one, Sherpa, I think, theirs was 50,000 per hand.
So there is a $50,000 hand.
They have particularly high-end sensors for each finger. That's where a lot of it is. So, okay, stop sharing.
The big issue, of course, with all of this stuff is going to be the long-term reliability of those things.
Yeah.
When you join.
Yeah. Yeah.
Did
That's what I'm
Did it-
curious.
oh.
So this has to have tiny little motors with a tiny little gears that are then running the worm gear. The worm gear may last, but those little gears, you wouldn't think that they would last that long. So
Yeah. We'll get better faster, that's for sure.
yeah. But
All right. Is there any club news that we need to cover here today?
Do we want to talk about the whole Homebrew Robotics Network thing?
Yeah, sure. Willie, go ahead.
Oh, before that, I heard hands. Did anyone say anything about Figure's new? They had a new demo
No.
with their new hands. I could share my screen actually.
Yeah, go for it. Is this Willie?
Yep, this is Willie. Ignore any hacking you see. Figure demo, whatever. Figure.
Now, Figure has an element of teleoperation to it, does it not?
It does. So this is fully automated. So not a teleop demo. They did need to get a lot of teleop data. The novelty here is that you could read the report that I actually could put.
oh,
I'll find it and put it in the chat. The novelty here is they realized they needed to add hands and they needed to have a system 0, system 1, and system 2. And their system 0 does a lot of learning to smooth out some of the movement. Can everyone see?
Yes.
Yeah.
It's open 6 a.m. 10 p.m. Friday, 8 a.m. to 5 p.m. Saturday and Sunday. The USO welcomes members of the armed forces and their families.
Are they actually selling this yet?
Only to enterprise, to BMW, but not to the public yet.
Okay. There's not a price on it yet, in other words.
And there's not a price. If I were to estimate it, I would put it at like the same as Boston Dynamics is, which would probably be
Priceless.
200. Priceless, yes.
You said it's
You used to work at Boston Dynamics, did you not, Willie?
Yeah, so I was 2 years. I was full time for a part of it, but also part time while I was doing graduate school. They had a new research. I don't know if you've heard of Boston Dynamics AI Institute or uh, Ray now. It's called Research and AI Institute, but they are their like AI research arm. And I did some stuff on the dog.
Well, Hyundai owns Boston Dynamics now, do they not?
Hyundai owns, yeah. They
It's Hyundai.
everyone owned them. So SoftBank, then Google,
Yeah.
and
Google
Hyundai.
owned them, yeah.
Yeah.
Yeah, the new Atlas is awesome.
Mm-hmm. A lot of people who leave the lab go and work. They're hiring a lot.
Mhm.
So you said this is fully automatic, this demo here?
Fully automated demo, as
Well,
far as I'm
how
aware.
do they teach the robot where the dishes belong?
A lot of data. As far as I know, they don't do any. Actually, I don't know. I would go into it, but
Yeah,
like object recognition is
yeah,
typical.
it is working. Yeah. So this is so this is one of the standard VLA demos that all the robotic startups are doing.
Mm-hmm.
So the training, yeah, so the training is probably done by pointing it out or web scale data. And in the input, they either send in the language or just hope for the best. I'm not really sure, but probably web
Is
scale
this Tony?
combined with text. Yes, it's me. The big
Did you
problem,
say
of
did you
course,
say
with
web skilled? What did you say? Web skilled?
web scale data. So I think Figure is actually using web scale data because they have like a pre-trained vision language model, which is something from like trained on YouTube or something. So that's part of it. But I'm guessing that there's text in there that's doing it. The Google ones are all web scale. There's like 100 companies all making these models, and they all get basically the same performance, and none of it ever can really like that's probably, we don't know how many times they did that demo to record it, but yeah, it's pretty clear that no one can get over 99% with these models now with pure VLA models.
Oh,
Uh,
is this a VLA
Vision language
video
action.
language action? This is a
Yeah.
VLL VLA. Thank you.
Yeah. So anyway, just like there's hundreds of companies doing this, and Google brute force searched all the different ways you could do it. So if you go and read all the Google papers, they cover this, and they basically brute force searched every single possible way to build a VLA,
Say
and they all
say
got the
Tony.
same results.
Say Tony. Is VLA a potential replacement for ROS, or is there a place where VLA
So
plays in a role?
VLA is just a network technology. It's just a neural network. So the input of the VLA is the vision input and maybe the robot state, and the output is actions. Oh, and language, text, goals. So you can actually use a VLA as a ROS node, or you could use a non-ROS framework for your VLA.
Okay. Okay.
Google used to use a non-ROS framework, and then they gave up and started using ROS and saved themselves a lot of time.
Is that the what do they call that TR2 or something? What's the transform technology that they got going?
The transformer, like they're all most of them are transformer networks. Like the
The
neural
VLA?
network is a transformer. It's a
Mhm.
transformer neural net.
Yeah. Yeah.
The other, they're all transformer neural nets. There's different ones. There's diffusion based ones, and there's just like normal ones, like decoding. They're all just different neural network architectures in the detail.
Nathan, we need to get Tony to give us a presentation on VLA sometime.
Oh God, I can give you a VLA presentation. It's gonna be super cynical because basically it'll be like, here's how we're spending $1 million. Here's the wall you're facing. Yeah, yeah, but if you
That'd
if
be
you want to
awesome.
see a great example, if you want to see a great example of the wall, go and take a look at Generalist's new VLA paper, and then figure out what it takes to get 99% reliability and our 99.9% reliability. And you start talking about needing more robots than atoms in the universe, I think, relatively soon. So, but you get to 20, to get to 99%, you need 20 billion robot years of data.
Using those methods.
Yes, but a lot of them, potentially there's some transferability, but actually all of them tend to behave the same performance with the same scaling loss.
What about quantum? What about quantum computing?
We need to use a non-neural network based approach. Yes.
Well, yeah, something. A better approach. We need a better approach.
I have a better approach. That's my thesis to be released.
All right, teach us.
Yes.
Teach us how to do it.
Yeah, basically we need to take all of the stuff that Camp does with Ross and do that, and then fill the holes with VLA instead of trying to do everything from scratch.
And this is, will quantum computing come into play in time to help?
quantum compute is going to be a ways off for this level of thing for a while. There are only there's somebody I work with that's been focusing on quantum computing. There's like about 1,500 quantum computers in the entire world right now, and they're up to what is it? 100? Oh, I forget now. It's either 100 or 1,000. 100 qubits
I've heard
is
it's
the
a
biggest one.
A
1,000.
few hundred.
Yeah, well, there's a distinction between the circuits and like the logic gates you can build from it or something. But anyway, they're very weird and interesting, but it's going to be a long time before they're practical for anything like this.
Say, Willie, you want to talk about the Homebrew Robotics
What's
Network?
that?
Yeah,
talk
why
about the
it's
network?
up and you can see
Yeah.
my screen. Basically it is
Breaking
a
crypto.
Discord channel. So if you go to the link that I put in the chat, you could join the Discord. I was hanging around different communities, like the Lee Robot community. Have some friends that worked on the Lee Kiwi, which I believe they did a demo with you guys. SO Arms, there's like this new XLE, not humanoid, bimanual manipulator embodiment for their SO Arms. Yeah, just a bunch of people that I met along the way. They were in like,
Nathan gave that Lakiwi presentation last
oh,
month or
beautiful.
2 months ago.
Yeah, I had someone from the Likiwi team asking about your ROS implementation. I was like, bro, like reach out to Camp, don't reach out to me.
Reach
So
out to
yeah,
Nathan.
I wanted to get a
Nate's on the
I
network.
joined their Discord and told them, hey, I did it. If you have questions, ask me. Also, I'm not far enough along to ask for help yet. I would have to spend most of my time figuring out how to use
The
help.
best way to learn is to teach.
Yeah.
Yes.
Yeah.
So yeah, I just wanted to get a lot of this like we'll call it next gen or new Discord type robotics community and get them integrated into like this larger homebrew robotics community. And this is
Very fine. That's good.
Yep.
Okay. Does anybody, let's see now, we're back to club news. Is there any club news? I think we finished that area. Let's move on. What I need help with is there's anything somebody's got like really pressing problems and need help with something. Now's your opportunity.
I've been working on getting Isaac Sim working trying to get remote desktop basically working to a server that's running that's able to run with the NVIDIA drivers. So I'm fighting my way through that, and then we should be able to get Isaac Sim working, and then we're trying to get the output from CAD into Isaac Sim to be able to simulate. So we're finally tackling that.
You know, I and Nola to play around with the gazebo. Oh, well, Nola, you've moved over to Isaac Sim, have you not?
I have started working with Isaac Sim, but I have not gotten it to work with.
Okay.
I have kinetic.
Yeah,
I have tilted, and it only works with Humble. So I have to bash out and get all my stuff to work on Humble so that I could connect it to Isaac Sim.
Well, I'm not that far. We're trying to get models to actually load and simulate, and then eventually we'll go there.
What kind of model are you working with, Stephen?
We're just designing joints. So right now, just some example models, but I've been working on some arm joint designs, and then I have this hand design that I've been trying to get designed in CAD for a little bit. Well, I don't know if Isaac Sim can do flexures, and I suspect we're mentioned like tendons might also be difficult, but we'll see.
What can't do what?
Flexures. A flexure joint where you have material that bends as the actual joint.
Does anybody else have a what I need help with, or maybe some kind of breakthrough somebody helped with, or something like that? If not, we're going to move on. You guys still talking?
It's just echoes.
Okay. Show and tell. Somebody got a show and tell? Come on now. Somebody's got a show and tell. Here comes Marco.
I brought my other Lekiwi base.
We appreciate you, Marco.
It can actually drive.
That's awesome.
I like that color.
So this is Teleop Twist keyboard, right?
Yeah.
With the holonomic wheels. Did you 3D print those?
I 3D printed pretty much the base and the wheels, and yeah. I
That is
also have
awesome.
the arm printed, but my
That is
printer
awesome.
is a little bit too tight, so I have to rework all the bases for the servos. So that's slow going.
Make your way to get.
Very nice. Hey, Jim, how you doing? Glad you can make it.
Omni-wheel drive.
Omni-wheel.
Is it Omni?
Yeah.
The ROS package is up. Oh, I can bump the thread again, because if you're using my ROS package,
Yeah.
you rewrote the servo controller, so.
What do you got? What do you got for a compute there?
That's a Pi 4 right now. Just one I had lying around, so.
All right. All right. Any other show and tells this evening?
I have one, a little video I made, and Big Orange
Go for it, Jim.
VLM related. Let me connect.
VLM. What's a VLM?
Vision language model. So I posted a bunch of shorts. If you go to my YouTube, the various things like Big Orange comes over to me, Big Orange searches the room model. These are all controlled by my brain now. Controlled by AI. So here's one where Big Orange is gonna using the VLA. It's called a Nano VLM, not VLA, VLM, vision language model, and it can get frames and describe what's in the frame using the in real time using Jetson Nano. Of course, you can't speak in real time every frame, so it has to just take a frame, talk about it, and then do it again. Going to the hall, describe what you see, and then come back.
First, I'll go to the hall and describe what I see. Then, I'll return here afterward. Let's get started. A white computer sits on the ground in front of a wooden cabinet. The scene is a bathroom with a mirror on the wall. The image shows a bathroom with a wooden vanity. Now, I'll head back home and describe what I see as I go.
Once again, all roads offer traveling to Denver, Alaska flight 3046.
The image is blurry and shows a person standing in front of a counter. The scene is a cluttered room with a television, a microwave, and a couple of chairs. The scene shows a wooden table with a television on top. The scene shows a cluttered desk with a computer monitor, a television, and a wooden file cabinet. On my way back home, I see a living room with a tan couch. Task complete. Let me know if there's something else you'd like me to do.
So, what AI are you using for this, Jim?
So this is running
Miles for Alaska Airlines.
no.
Flight 2185 service to Hayfield, gate 22. Looking for Miss Reinhardt.
An NVIDIA optimized.
Hey, Cam, your audio is overrunning everybody else's audio with those.
Where is that coming from? There's
He's in the airport.
Oh. Yeah, you might want to mute. Use the space bar to talk, and you can mute. That's the standard way. But so this is what I'm doing here is using these models that were made for the Jetson Nano, and you can go to the NVIDIA website here called the Jetson AI Lab. And can you see this? This is the one I'm partially showing this one called Nano VLM. It uses lava. It's using via a visual language model, and it uses like the clip algorithm or clip model to determine what's in the picture, and then models like Vila or Lava, and these are the ones here like called Vila, and these are small enough to run on onboard the Jetson Nano, which is 8 gig. It's only 8 GB of RAM of unified memory for both the operating system and the large language, the models. So these are kind of small language model in a sense, and it's vision based. So this is all here, and you can run it on various levels of Jetson Nano. I recently purchased this one too, so I'm going to have some pretty powerful stuff going on. The AGX Orin 64 GB. It went on sale for $1,000. It was normally like 2,000, and the one you can get for $250 is this one, the Orin Nano 8 GB. I'm sorry, did you say something?
Yeah, that's the board that's in the Sprout.
This this one, the AGX.
Yes.
So this one, I have one here. It's I haven't really used it yet, but it's kind of a reasonably large cube. But it's it can easily fit on a larger robot. Um, and it is very low power compared to your 3090 or your 5090 on a PC. So this thing is a low power device and offers 275 trillion integer operations per second. And they sold them for 1,000 half off recently because of the newer models that came out from the new model that came out from NVIDIA, which is that now I forget the name of it. You please remind me.
Thor, Blackwell
Thor,
based.
yes. NVIDIA's Thor.
They have Thor's on sale too, a little bit, 20% off. Dang it.
Oh, okay. Yeah, but those are expensive, like $4,000.
I think I did.
Or maybe you did. If I missed it, that's
So anyway, yeah, can check out my videos of these other things. They're only like seconds each, but I don't want to take time now. But so I've tied in all what's called the Lang graph to control all these features of the orange by providing tools and providing feedback from the Nano VLM. So that's like a tool, and the AI connects all these activities together. It's really I'm giving control over to AI in a sense to the all the things that I've done with Orange over the years are now being have been converted to tools that the AI model can access at its will. So it takes your language, converts to actions, and then responses as well. Voice responses, text responses, which are then read out as voice. So anyway, I'll give you an update next time.
Yeah, I might add that Big Orange is a DF robot, right? Delta Frank.
Slam Tech.
But you buy it through DF Robot, right?
Yeah, the Big Orange chassis there is still available. It's kind of an old design pancake robot, but you can still buy that chassis. It's got, the big wheels that make it easily traverse carpet and floor. It can stumble over a large wire protector like that I have on the floor, but otherwise it can handle pretty good carpet and regular hard floor. And that was like $600 or 500, yes, around 600, 500 something dollars. And but it's sort of an old design, that orange thing, and it's low to the ground. I'd want a robot that's taller, as Thomas has pointed out. Why don't you build a thing so it goes up to human height?
You can buy the motors and wheels separately.
Yeah,
So
yeah.
I did a thing this week. I went to the I think it was Gaylord's conference center. Anyways, I went to Digital Realty conference. These guys make data centers. They got like 300 data centers, and it's in San Diego. This is the G1 robot. We call him Greg.
Luggage and parking. Let's use that at all times. Do not see your luggage and parking.
I walked him around in the hotel. That's always fun. I can't do this. This is the inexpensive. This is Greg. He's the inexpensive $20,000 tow bar life robot. We were at the Digital Realty conference. These guys make data centers, and the chief technical officer, Chris, I can't remember his last name, Sergey or something. But the gag was that when he came up the stage, Greg went to the stage instead of him and started acting like he was the CTO, and eventually Chris, this is Chris on the stage here, came up and Greg went back in the corner and, kind of just saying, but anyways, yeah, this is part of the presentation here. They did a Top Gun thing. This is all their guy. Oh, this guy did a little presentation on quantum computing. There's actually some quantum computing in their data banks, or their data centers. So they're using some quantum computing. And this, he was talking about the scale, the levels of it. And you were saying 100,000 million, blah blah blah, and he was saying that they were in the 1,000 level. However, they calculate quantum computing. So this is Greg walking down the hallway here. As soon as my video catches up. But I had a lot of fun because the case was broken and I couldn't wheel him. So I had to actually put him in the car and walk him to the hotel and walk him out of the hotel. I was walking him everywhere. It was awesome. People looking and waving and stuff like that. Yeah, so that's what I've done earlier this week. Is there any other show and tell? All right, let's go ahead and
did you use the robot to use the high occupancy lanes?
Yeah, I could have. There's one other thing. Let me share this. Patience is a virtue. So this is Tobar Life. We distribute Unitree robots. We do program development and do special events. And so they send me out on the special events to run the robot. But this is the G1 Basic for 21 grand. The educational unit with the Orin board is 43. And then you can put as much money into this thing as you want. We've got 3-fingered robots, I think, for 56. And if you want the 5 fingers, you got to put like 70 grand into it. There goes 67,000. I'll put this link in the chat. All right. Is there anything else before we get into the presentation here?
Do not transport any item.
Going once, going twice. All right, let's start this thing. Are you ready? This thing on?
It's working fine, Cam.
Yes, let me share my screen here.
all
Boom,
dead
and boom. Mhm. How do I get back to, oh, hmm. Let's do this. Let's, okay. I don't want that. I need to spell my website right.
As a reminder, wheels device including but not limited to bicycles, skateboard, hoverboard, and wheeled footwear are not allowed on the sidewalk or in the terminal.
Patience is a virtue. Here it comes. Bear with me. Okay, here it is. The mockbot. Okay. I'll put this in the chat. I guess I'll post it to the mailing list later so that folks that don't have their computers with them can get the free PDF. Okay. We're going to start a SIG, a special interest group on Mondays because Monday's blank. And we're going to be focused on the mockbot, building this mock turtle bot. I think it's a great beginner project for Ross. We'll still do the Ross discussion group on Tuesdays. The Ross discussion group's gotten quite advanced, and so this will be an entry level, for folks that are interested in Ross. So let me put this PDF in the chat. There it is. All right. That's a free copy of the mockbot, a 1995 value, well worth the price of admission.
Thank you.
You're welcome. Yeah. All right. All right. So I've given you the PDF, and I'm about to, let's get into the book here.
The USO was located from Terminal to American Airlines Sky.
So in doing this, I think a couple of things really stood out in the project. One is the mockbot URDF. We've got a standard URDF. It's like the Roomba with a LiDAR and the ultrasonic laser and a camera. And then base laser to base link transform, which is really important for the LiDARs, because if you have a base link if you have a base laser to base link transform, on your LiDAR, you can pretty much Velcro it to the base, which has base link, and then drive it around with SLAM toolbox. It'll pretty much start mapping out of the box. Let's see here. Bear with me. Are you seeing the screen for the mockbot? Hello, is this thing on?
Yeah.
Yeah, you see it.
We're seeing the first page.
We see the web page. But you're showing your whole desktop. You might want to focus on that. Yeah.
You need to click for it.
Test 1, 2. Can you hear me okay?
We can now. We didn't hear you for a little bit there.
Yes.
Yeah, I need to log back in on my phone real quick because it's out on me. Hang on a second. I gotta go back on the phone. I've got, computer on.
We want to make this, do we have to buy a robot?
Sorry about this. Hang on.
There's some hit a button. There's some alternatives. So probably an alternative nowadays. So what was the one? Yeah, Hackerbot's one where they specifically contracted with a kind of a generic robo vacuum and then integrated with it. So
What do you need,
Cam?
Cam?
Can you let me in?
You're in, Cam.
Manual and how to build it. It's pretty expensive.
Can you hear me okay?
Yes. Now we can.
Wall to wall and treetop tall.
Can you hear me okay?
We hear you, Cam.
Yes.
All right, thank you. Sorry about that. Okay, so here we go. The mockbot. I've already put the PDF out there and mentioned that we're going to have Monday night mockbox SIG. That's in addition to the regular Ross discussion group on Tuesdays and the AI SIG on Thursdays. Yeah, like I was saying, in this book, the main things for me was the Mockbot URDF and the base laser to base link transfer and the homebrewed ultrasonic sensor. I think those are the big three things, but I'm just going to scram through this thing real quick. And again, we're going to be focusing on this. I think it's a good entry level for Ross on Monday evening. So here we go. The Mockbot, over-the-shoulder instructions on how to build your own personal robot by featured homebrew roboticists Camp PB, Dr. Alan Fetterman, Ross McCary III, and Thomas Messerschmidt. So here's the preface. The concept is a smart table. Smart table is a tray table that can reliably get from one place to another. The low-hanging fruit is the robot vacuum cleaner. Ideally, I'd think you'd do this with a 5-inch wheels to be able to roll over thick carpet and get through floor carpet transitions and stuff like that. But that requires another whole level of engineering, taking advantage of the robot vacuum cleaner. We're basically building a duplicate version of the TurtleBot. TurtleBot's the standard research hobbyist platform for Ross. And we're building it like 3 different ways with Roombas and BotVacs and the Create 3, which is actually a refurbished educational Roomba. But anyways, so here's the preface. And I'd like to thank the following individual, Dr. Ed Katz, for helping me out. We'd meet on Mondays and he'd go through the project with me. Mike Wimble, Marco Walthall, for helping with for actually making the homebrew ultrasonic sensor, Ross ultrasonic sensor, which is basically taking the simple publisher tutorial from Ross and displaying the simple hello world text message with an actual range message. We also make a URDF for that so you can see it in your RViz, the visualizer, and we've made a nav2 YAML so that it comes into play with the navigation. Also, something that was interesting, and Mike Wimble pointed this out, was that when you ran it with Python, it had all the time to do the timing to get the appropriate measurements out to 12 meters. But when you ran it through a Roth node, there wasn't as much time. So when the distance went beyond like 1.5 meters, the readings would become very unstable. And so we shortened the distance down to 1.4 meters, and it actually navigates pretty well. You'll see that later on. Also, when you buy the book, send me a PDF, MarkBot PDF. We'll send you the PDF. This really doesn't make much sense on dead trees because it has long commands and links and stuff like that. So it's much better in a digital document. Okay. Can you hear me okay?
Yes.
Coming through well, Cam.
Thank you. Thank you. Okay. So here's the chapters. Okay. The Turtlebot, building a ROS2 workstation, making the robots compute, meet the mockers. It's all about that base. Meet the mock bots, LiDARs, cameras, and other sensors, navigation, putting it together, and looking forward, and tips and troubleshooting. Okay. So here's chapter 1. We're selling the reader on the Turtlebot. Again, this is the standard research hobbyist platform for ROS. Here's a little bit about the history of the Turtlebot. The Turtlebot, I think the origin was, what is it? Is it Indian, where they say turtles all the way down? So we are calling it the mock Turtlebot, like Alice in Wonderland, mock turtle soup. Turtle soup was a delicacy back in the 19th century, and they had mock turtle soup that's basically made with cow's brain. But Alice in Wonderland had the mock turtle, so we've got the mock Turtlebot. Mock Turtlebot was made by Melanie Wise and Tully Foote, right? Did I get that right? Yeah. Anyways, moving on. There we are. Who are we? Alan, myself, and Thomas have written a few articles for Servo Magazine. The intent of this project, we don't guarantee the accuracy, completeness, or timeliness. In fact, you're always on a moving platform. You put stuff in, and all of a sudden it's obsolete. But that's the nature of the technology. Also, we're not responsible for what you do, so that's our liability disclaimer. Not meant to discourage you, but to prepare you for a challenging set of tasks involved building a complete robot, much to learn. This is going to be one of the greatest technical revolutions in history. Here's key features of the Turtlebot. Scalability, I think, is the main thing because educational robots are generally tabletop robots, and you need something able to carry some weight and a payload to actually be useful. So we're trying to get into the space of an actually useful robot. And to me, the low-hanging fruit is just making the tabletop the end effector, okay, which goes against normal convention because generally a manipulator, is active, a soldering iron or a hand or something like that. But we're viewing a component of the robot as the end effector, okay? So here we get into the concept of a personal robot. Everybody knows Rosie the robot. And Thomas worked at Topos, and I think you knew Nolan Bushnell. Knew Nolan Bushnell, right?
Yeah, that's right. You still keep in touch with his son these days.
Very fine. And there were popular robots in the 80s. The old robots, I think many of us had the Hero Junior robot or even the Topo robot or different robot. Thomas, Alan and I traded Hero Juniors back and forth. I thought sometimes holiday junk exchange 3 or 4 times. I ended up with both of them. One of them is still functional. I've stripped the other one down. Maybe I'm not the guy to do retro, but I see where the Hero Junior, it might be interesting to do a ROS application on it. It'd have to be a different transform, but anyways, interesting stuff. So these are like, here's something interesting, the early HBRC. This is Dick Prather. He was the original president of the Homebrew Robotics Club. He made a robot featured in the movie Created with Peter O'Toole. That's it. Check out this movie. It's a good movie. This is the robot that Dick Prather made. There's Wayne Gramlich and Bill Benson. Wayne had a robot that was I think they called this Wildcat or something. It was popular for a while. It chased like an orange ball. It was no, this is Chuck. That's not Wayne, but Chuck McManus. He was our second president, I believe. but he had this robot that Wildcat, I think it was called, that basically chased the ball around. And it was funny because it hit the ball and it sprang off somewhere, and the robot would go chasing after it and stuff. So good times. That's early HPRC. Multiple parts to this project. Create a ROS2 workstation. Program and install ROS2 on the robot's controller. Choose a robot base, either the Roomba, BotVac, or Create 3. Add the LiDAR and end effector, that's the tabletop. Add LiDAR camera and other sensors, and then create a map and navigate. That's the goal here, is mapping and navigate. After accomplishing these steps, you're on your way to total world domination. ROS is the de facto standard framework for robotics, and the TurtleBot is the standard platform for ROS. Here's a link to our mailing list. Okay, so get folks in on our mailing list. We recommend this stuff. Here's some unconventional homebrewed robot building materials: alien tape, duct tape, Instamorph, a polymer film. That's poor man's 3D printer. It's a thermal polymer. It's little beads you put in water and the microwave and heat it up, and you can mold it into whatever shape you want. And when it cools, it hardens. So that's useful stuff. Scotch mount, indoor double tape, 5-minute epoxy, Gorilla hot glue gun kit. Anyways, you get the idea. Okay, so next thing, the thing you want to do first is build this ROS2 workstation. Okay, so this outlines. Get yourself, go to Goodwill or something, get yourself a ratty old virus-infested portable computer and blast it with Ubuntu. This is, okay, there's introducing ROS, okay, and here's a little bit on the PR2, okay, that's the $200,000 robot. Actually, I think somebody said 400,000, but anyways, that's the robot you had go to the, bring coffee to your professor, right, Tony?
Yeah, and that thing nowadays, probably due to inflation, it'd be worth about $1 million.
PR2.
Yeah.
What did you say? How much was it?
When it came out, it was worth like 500 grand. That's what the sales price was, but that was sold at a loss. I have no idea how much those things were worth internally. It's hard to calculate because, so much R&D for so little robot shipping. But nowadays, because of like inflation and whatnot, probably be worth close to $1 million is the price you pay for that.
But it's kind of funny.
So yeah. But a lot of that, the other big cost in there is like there's a lot of sensors that, for example, this was one of those things that was really sad. We had a $10,000 stereo camera in the head. Maybe it was 20. It'd be now Trey's $20,000 camera. And about a week after we released the robot, the Kinect came out and blew away the performance of the stereo camera. So that was,
I remember that.
Standard cost reduction right there.
No, I remember that. It was this robot that you had. I think it was actually duct tape on the thing, wasn't it? It had a Kinect on it. Yeah, that's the PR2. And I remember we had a ROS discussion panel, and Tony, I think you were on it. Melanie Wise was there. I don't know if Tully Foote was there or not, but I asked the question why the TurtleBot wasn't more popular, and I got booed. Okay, don't get me wrong. It was a simple question: is why it was popular, but why wasn't it more popular? And Melanie told me that was it Scott Hussein? It was they wanted you guys focused on the PR2, not the TurtleBot. And so, anyways, that's the PR2. That's the original prototype robot for ROS, and it was used in the universities and so forth. So here we go, Ubuntu. This carefully step through the above instructions. This tells you how to, this downloads the ISO so that you can burn a thumb drive and install Ubuntu on your workstation, okay? So carefully step through those instructions. We recommend Ubuntu 24.04, the latest long-term support version for Ubuntu. It's good till 2029. And also, as far as creating the thumb drive, Windows has disk management that's supposed to be able to do that, but I just went around the horn and couldn't get it done. So I'm recommending Rufus. Rufus is used to transfer the ISO to the thumb drive so that you can boot off of the thumb drive, and you got to look at your computer and Google and whatever to figure out how you boot off the thumb drive. But when you boot off the thumb drive, it will give you an option to either run Ubuntu off the thumb drive, make a dual boot workstation, or we recommend making it a dedicated Ubuntu workstation. Okay. Are we there? Yes?
Coming through loud and clear, Cam.
Thank you. Okay, boot the workstation. Okay, when you boot the workstation, again, we recommend you make it into a dedicated workstation. Now abandon hope. How's your Linux, right? Don't worry, if you stick with ROS for long, you will become familiar with Linux, okay? So here's the terminal, Control-Alt-Delete. Your first command is ls. We're going to change directories. Install Vim. You might use VI. VI, my old friend. There's also Nano. Little tricks, Alt-Tab to scan through the windows. Another neat trick is in the terminal window. Hit the up arrow. That'll give you the previous commands. Here's copying and pasting in the terminal. And then when you want to kill the program, it's Control-Z, all right? Or you could type exit. In general, when you kill a program, it's Control-Z, and you want to exit the terminal, it's exit, okay? Linux commands. Here's a little bit about Linux commands. And we talk about man pages. TLDR, too much didn't read, too long didn't read. If you do a man page on LS, for example, it's like 4 pages. Anyways, here's a tutorial on Linux from Ubuntu, okay? So now we have a workstation with Ubuntu on it. The next step is to install ROS. And so you basically carefully step through the above instructions, okay? These are your ROS installation instructions, okay? And we recommend that you install the desktop version. That's got the visualizer and all that. And then you need to download the development tools so that you can build build apps from source, okay? Here's setting up the URDF. Okay, this is getting into the ROS tutorials, okay? Again, carefully step through the above instructions, creating a URDF, okay? Universal robot description format. Oh, I know. Tim calls it an URDIF. So URDIF is Universal Robot Description Format. Okay. The tutorial creates something called the SAMbot. It's a little differential drive robot. Okay. Now what we've done is we've made a mockbot URDF that you can substitute for the SAMbot. This talks you through substituting it. You go out to my GitHub and get the code and just displace the SAMbot code with the mockbot code. And when you run RViz, you'll end up with something like this. Sorry for the delay. I'm running as fast as I can. You'll end up with a URDF like this. Okay, you see it's the mockbot. It's got the Roomba base, the LiDAR, the ultrasonic sensor, and a tabletop. So that's one of the things is we've made a mockbot URDF that's used for the project. Here's a little bit about GitHub, and here's a little about VS Code. Here's a bit about Gazebo and a link to the Gazebo tutorial. Shout out to Lino Robot 2, one of our favorites. Some time ago, we were talking about a standard ROS-based robot, and there was a lot of emails floating around, a lot of links, and so on and so forth. And we kept coming back to this Lino robot. And so my thought was that if we were going to make a standard homebrew robot, Linux, ROS-based robot, the Lino robot is what that should be, okay? I'm having to talk over the announcement here, so there's a link to the Lino robot. Also, here's the ROS tutorials, okay? So we're getting into ROS tutorials now. One of the big starting things is something called Turtle Sims. It gives you a virtual robot turtle, okay? And then you run teleop. Oh, So you run, okay, let me back up here a second. What you want to do, this is, yeah, we're running the TurtleBot sim and we're running the TurtleBot, we're running the Turtle Teleop keyboard, okay? So this is TurtleBot sim or Turtle sim node and the Turtle Teleop keyboard, okay? The Teleop keyboard is a publisher. Turtle sim is a subscriber. So when you publish from the Teleop keyboard, it publishes command vel messages. These are velocity messages, either linear or angular velocity messages. Linear is forward and backwards, and angular is clockwise, counterclockwise, or one or the other wheel turning back and forth. Okay. So the idea here in the ROS2 tutorial is you launch the sim, you launch Teleop keyboard. Now here's a few ROS commands. You can node list, topic list, and then topic echo. Okay. So the node list, if you ran node list, it would show you the ROS nodes that are running. Teleop Turtle, that's the Teleop, and Turtle Sim. Teleop again is the publisher. Turtle Sim is the subscriber. You can run the topic list. The messages run through topics, and you see there the command vel and the turtle and the turtle one topic. Okay, if I do ROS2 topic echo for the command vel and I operate the Teleop keyboard, you'll see the linear, and if you drive forward or backwards, this is forward, you see the axis and linear going too. That's in meters per second. So the robot's moving forward when you press the I key in Teleop keyboard. Again, the point here, and the point here is that in ROS, it's a publish and subscribe architecture. And the Teleop keyboard is publishing and the Turtle Sim is subscribing. The concept here is that you can parlay that into teleoping a physical robot, not a robot on the screen, okay? And so that's the idea. Moving forward into the ROS tutorials, here's creating a package. Again, carefully step through the above instructions. And here's writing a simple publisher. Again, carefully step through the instructions. This will be hello world. Your simple publisher publishes hello world, and the listener node subscribes to it and reports back hello world. Okay, we will use this later in our ultrasonic ROS sensor, where we're displacing the text hello world with a range message from the ultrasonic sensor. Don't panic. Here's a complete list of the ROS tutorials. Finally, on the workstation, you need to install the nav2 navigation package. You do not install the navigation package on the robot compute. That's the Raspberry Pi. Okay, and so now we've got a ROS2 workstation. Now we're going to start making the robot compute. We recommend. Okay, here's a little bit about Pi 4 and 5. But we've discovered that the Pi 5 requires some special power, and I'm using a booster board with a battery bank USB-C -PD power delivery or quick charge. Other ways to do it might be through a buck boost converter and using RC car batteries. These extra expenses and things might be an argument for stepping back to the Raspberry Pi 4, which of course can be overclocked too. So anyways, here's Raspberry Pi Imager. See, this is the link to that power board, okay, for the Raspberry 5, okay, and a little bit about power stuff with the Raspberry 5 anyways. So here we go with the Raspberry Pi Imager, installing Ubuntu on Raspberry, okay? So go to the Raspberry Imager, type RPI Imager and then RPI Imager, and it'll launch it. Or you can go to Show Applications and search for Raspberry Pi Imager, and you could put that on your favorites on the Ubuntu GUI if you'd like. So when you get into the Raspberry Imager, click RPI Imager, run the imager, or click the Show Application. Okay. So when you get there, you want to choose Other General Purpose OS and scroll down to Ubuntu. and choose 2404. Okay, at this point, have the micro SD card plugged into your computer. Okay, choose storage. Choose the micro SD card. Right. Be sure and choose the micro SD card. Do not format your hard drive. This should take about 15 or 20 minutes. Boot the compute with the micro SD card. So you take it out of the desktop and put it into your Raspberry Pi and boot it. You play 20 questions. We install the desktop version. Also, we recommend that when you start off with the Pi, have a keyboard and monitor attached to it. Okay, it just makes life easier. And again, install the desktop version of Ubuntu. So you play 20 questions, you know, Wi-Fi network, computer name, you know, all those kinds of things. And then you're going to want to ping back and forth between your Raspberry Pi and the workstation. SSH, you'll have to install SSH, but now you want to SSH to the Raspberry Pi, and it'll come up with a terminal screen as if you were typing on the Raspberry Pi, okay? Now we want to install ROS again, but this time on the Raspberry Pi, okay? So you'll either have it attached to the monitor and so forth and attach it that way, or if you've SSH'd, you can use the website on your compute, your workstation, and copy and paste, install it that way. But again, we're installing ROS again, but this time on the Raspberry Pi, okay? Again, install Jazzy, which is the latest long-term support version, and install the tools, okay? Now you want to create a workspace on the Pi, and this will be so that you can compile from source code that you'll want to use, okay? So what we have now is a workstation and a generic Raspberry Pi with ROS installed on it. Be aware we're going to have a variety of bases, including Roomba, BotVac, and Create 3. And the configuration of the Raspberry Pi is going to be different from each. So again, what you have now at this point at Chapter 4 is a ROS2 workstation and a ROS2 Raspberry Pi. Okay, now it's all about the base. You want to choose your base. And we've built the mockbot from 3 different bases. The Roomba. Here, a Roomba. You pop the cover off. There's a 7-pin sub-miniature DIN. There's a special cable that you can get with the 7-pin sub-miniature DIN out to a Type A USB. It also includes the 5 to 3 volt leveler, and so that it can talk to the. You plug that into a Raspberry Pi, and it can talk to the Roomba. You'll want to install the software from Autonomy Labs. Okay, and run it. And basically, at this point, if you can run the keyboard, teleop twist keyboard, and if you can teleop twist keyboard your Roomba, it will run when you've got nav2 running. So that's it on the base. Okay, the Nito BotVac. I worked at Nito for 13 years. I saw it all. In 2010, Mike Ferguson made the BotVac node, and that's how I learned ROS. It's kind of funny. I spent 2 years locked up in a server room, forced to learn as much Unix as I could stand. And when I first launched Linux, it was like, VI, my old friend. So it was pretty nice, a blast from the past. But anyway, so this is the ROS. This is the BotVac package. Okay, the BotVac package, carefully step through the instructions, is complete because the BotVac includes the LiDAR. So the BotVac package has it all. It runs the LiDAR and driver and so on and so forth. Here I talk about how to take the dirt bin out. Yes, disassemble. Battery bank in the dirt bin with a Raspberry Pi. There's a micro SD card. There's a micro SD socket in there that you can plug into, and you drive the robot with that. And so again, here, like we did with the Roomba, you've installed it into the BotVac and you're driving it around with teleop keyboard. If teleop keyboard can drive the robot around, it will drive around when you run nav2. And so that's the Roomba base there. Create 3 is probably the easiest. Create 3 is the educational version of the from iRobot of the Roomba. Basically, it's made from refurbished i5s. And when you boot it up, it's automatically running ROS too. So you just need to run teleop keyboard on the same network, and you're driving it around out of the box. So that's the Create 3. Now we're Meet the Mockers. Who are these guys? That's me. That's me with the TableBot Challenge. I graduated from FSU. If I'd graduated on time, I'd have been selling advertising for the local newspaper. I graduated 2 years late, and the last project I did was on Apple Computer, so I went to work at the Radio Shack Computer Center on Monroe Street, and have been this was '84, and thought mobile robots are microcomputers for the 21st century. So I focused on building robots as a hobby and packed my bags, moved to Silicon Valley in '84. Best move I ever made. And in 2005, I think it. Anyways, I worked at Nito Robotics, of course, for 13 years. But anyways, yeah, this how to build your own self-programming robot is a big influence on my life. David Heiserman built it. It's a book. It features machine intelligence, and I've actually in the homebrew robots did that with an Arduino. But anyways, highlight of my life, I won the '96 Autonomous Robot Wars, Gladiator 1. The Robot Wars was the predecessor of BattleBots. And this wasn't remote control, this was autonomous. Godfather of the HBRC Challenge and the TableBot Challenge. Got the bronze medal, Robo Games. Wrote Homebrew Robots a couple of years ago, and now we've just published the MarkBot. So that's where we are. Dr. Alan Fetterman, take it away. Alan, you out there?
Oh, yeah, I'm there. I just wasn't sure if I was muted or not. So, gee, I got into robotics. I was interested. I mean, I tried to build a robot that I saw in Omni magazine back in the late 80s, early 90s. I was a little interested in Beam. And then I came to, I'm a geologist, oceanographer. I came to Silicon Valley to work for the USGS as a civil servant, and I got caught in the first riff. So I had become a webmaster when I was at USGS, and after I lost my cushy government job, I started working as a contractor for NASA, mostly doing web design, and then got into streaming media before anyone knew what the hell that was. And part of that was supporting something called the NASA Robotics Education Project, which was, teaching kids how to be robot engineers. So I got involved in that and was very successful, winning national competitions and things. And then I got involved with homebrew robotics after I left NASA. And we won the Connect Challenge. We did second place for the NASA rover recovery stuff. And I started working with Ross and also working with a group called Ubiquity Robotics, which still makes robotics, but they are out of Slovenia now. I still talk to those guys. So those were the Magni, and a lot of people from Homebrew were involved. Tony was involved. Wayne was involved with that, some other people. And they're still making robots and doing Ross. And got involved with Homebrew and did some fun things. Like I had my first what I call Gopher, which stands for General Purpose Household Robot. Then this was my first Gopher, had a Nerf pistol. It also had a spatula and it had a broom on it. So it was my burger flipping, broom pushing replacement for a 55-year-old engineer, out of favor software engineer. And had a lot of fun with it. And unfortunately met camp and got involved with camp.
Alan, I think you and I joined the Homebrew Robotics Club the same year, 1996, 30 years ago.
No, I think you were there in front of me because it was the first time we met was in that, was it the library in Cupertino or
yes,
middle
but
school?
Now I went to the homebrew club in 84, 85 when it was meeting at Alza with Dick Prather, and life got in the way and I got away from it. But when I was at the Robot Wars, Frank, I can't think of his last name, was there, and he says, "Oh, you should go to the Homebrew Robotics Club." And I told him, "Oh, I used to go to that," and that's when I went back. But you showed up shortly after that. It was like 96.
I don't know if it was that early. It could have been. I started NASA in 95, and I didn't really get involved in robotics
It
till
was
like
right around the same area.
97, 98. But anyway,
Yeah.
who knows? Who can
Yeah.
remember that far long ago?
30 years passes in a
Yep.
hurry. All right. Is Ross out there? Ross had trouble with his computer today. I told him to log in on the phone, but I don't think he's out there. Anyways, Ross Lunan, he's one of the mockers, and he's built the Turtletron, and Turtletron is based on Create One, like the original Turtlebot, and he's worked with Mike Wimble and Sergey, I believe, quite a bit, and we'll cover some of his robots later. But that's the Turtletron. Phil's moved to Arizona and has had some time trying to catch up with, but he's one of the Southern California guys. And here's some of the things he's done. And him and I think it's Martin Mason, recognized early on the importance of the Turtlebot. And I knew he was a big fan, and that's why I invited him to join the Mockers. And he's built it from Aruba. Thomas, tell us about yourself.
Told you I got the flu and I got a sore throat, so I can't say a lot, Camp. But yeah, I've been building the mock bot here, and my spin on it is I want to get as much AI working in it as possible. I'm still midway through. Yeah, that's one of my robots. I like to build life-size humanoid robots. One of mine does walk, but most of them just ride on top of pedestals. That's it, Camp. I'm just under the weather here.
Yeah, this is Alan. Interesting aside, my first Turtlebot was built from a Roomba that was donated to me by Melanie Wise.
We used to have a club Turtlebot too that we traded around.
Yeah, and then Steve O'Kay, who I think was at Willow Garage for a while, when Willow Garage folded, brought by like eight or 10 Turtlebots that we gave to members. They were disassembled. They were the Roomba base and the panels, the plates, and the standoffs and things like that. And then there was a group by Greg Maxwell called SV Ross. I think that the meetup still exists, but is not active.
Yeah, and you guys did used the bot back.
Yeah, we use bot backs to teach the class.
SB Ross, and is it Ralph Gannock, I think, did the launch files that included the URDF and stuff like that.
Yeah, I think that was Ross One Electric. No, maybe Noetic. I don't know.
Yeah, and James
10 years
Nugent,
ago.
James Nugent did the Ross 2 upgrade, which we use today. Thank you, James.
Yeah.
Okay, so meet the mock bots. These are the robots that we've built, okay? And my robots are Smarty 1, Smarty 2, and Smarty 3. Smarty 1 is based on the bot vac, okay? And there's the GitHub to do the download for the bot vac package. Basically, yeah, this is telling how to set it up, okay? And once you've set it up, I basically run through my cheat sheet as to what to do to get it mapping and navigating. So for mapping, first off, you launch the base, then you launch teleop keyboard, then you launch the SAMBot URDF or the UDRF. That gives you the mockbot URDF, okay? Universal Robot Description Format, URDF. Okay. Then you launch the, I used the TurtleBot 4 package. Okay. But then you launch Slam Toolbox. Hang on a sec. Looks like I got a problem with my connection here. Give it a minute.
Take up. For effective slide, please register only
So here we are on the cheat sheet for Smarty One. Smarty One is the, can you hear me okay?
Yep.
Yeah.
Smarty One is the bot deck. And so you basically, yeah, we've launched Teleop, we've launched the bot deck package. And then you launch the SAMBot description, that'll give you the mockbot URDF. And then you launch Slam Toolbox, and I'm launching it from the TurtleBot 4 package. And then you launch RViz, the visualizer, okay? Up comes the robot, you drive around, you make a map, you save your map, and that's how you do mapping, okay? Navigation, you want to kill Slam Toolbox. I usually kill the RViz, and then you launch the localization launch file. That launches the map server that loads in the map that's just saved. It loads in the localizer. I'm using AMCL, Adaptive Monte Carlo Localization, and it loads in Life Cycle, which tests the status of the nodes. And then finally, you want to launch, there's navigation. You want to launch Nav2, that launches global planning, local planning, recovery behaviors. And then you want to launch RViz, that's your visualizer. And then you can click on a point in the map, the robot will automatically navigate. That's Smarty 1. Smarty 2 is created with the bot, with the Create 3, okay? And it's the same kind of thing. I use the LD06 LiDAR there. The bot deck automatically comes with a LiDAR, so the package is all in one, okay? But with the Create 3, again, it's got ROS built in, so you boot it up, and I put the DL06 LiDAR on there, which is cool because it includes a base laser to base link transform. So you can take it and Velcro it to the base. The base has base link, and so you drive it around with Teleop keyboard and Slam Toolbox, and it pretty much maps out of the box. And so it's the same thing. Here's a cheat sheet here. You run the Teleop keyboard, you launch your LiDAR. I launch the camera. That way, if it's out of view, you can still drive around and map. And then you launch again you launch the SAMBot, which is modified into the MOTBot. URDF, okay? Now I want to launch I'm sorry. This is mapping, the same kind of thing. You launch mapping, RViz, you drive it around with the map, you drive it around with mapping, then you save your map, okay? Then you kill Slam Toolbox and RViz, and you launch the localization launch file, which again launches map server, localization, and lifecycle. You launch nav2 again, which loads global map, local map, recovery behaviors, and you'll launch the RViz, which is the visualizer. It'll bring up the local cost map, the global cost map. You can click anywhere in the map and the robot will autonomously navigate there. Also, the Create 3 has some neat features, including docking and undocking, so that if you're near a docking base, you can run the dock action and it'll automatically dock. Also undock, and that, they spent a lot of money doing it. Also things like battery state and stuff like that. But finally, my Smarty 3 is built off just a plain old Roomba, and through this whole project, I've really come to the conclusion that a plain old Roomba is the way to do it, okay? That's Smarty 3, the Roomba base with RP LiDAR. Those are not real eyes, okay? And the same kind of thing, this is my cheat sheet, mapping and navigating. So with the mapping, you launch the keyboard, you launch the RP LiDAR in this case, you launch the base unit, or actually with the Create 3, it's automatically running, okay? Oh, I'm sorry, this is the Roomba. So you launch the Create 3 bring up from Autonomy Labs, okay? And launch your SAMBot description. Again, they give you a MOTBot URDF and navigation and RViz, the visualizer. That's mapping, save your map. Now we're navigating, kill nav toolbox, load localization, load nav2, load RViz. You need to set your pose on the map, and then you can click anywhere in the robot will autonomously navigate there. So those are my mockbot. Alan, you want to talk about Gopher?
Sure. Well, I have two. Gopher 1 is based on a Nito, and that one has a Pi 5 in it. And that was a little problematical because I'm powering it with just an old style buck converter, and that power system was kind of flaky. So it's running the botback code. The standoffs are aluminum rod that I've tapped and drilled. We give detailed instructions on how to do that. Uh, let's see, it's using a Raspberry Pi camera. That also is quite difficult because uh, the software on a Raspberry Pi 4 that does the lib camera. Actually, there's a whole long discussion on it just in the homebrew mailing list today by Pito. But Marco figured it out around 2 years ago because Marco is very smart. And we have the camera working. And of course, that's using the built-in it's not a LiDAR, it's the radar distance finder, and that's working. Another thing that I've discovered is something called laser filtering. Because the camera is on the base of the robot, you get reflections off the struts that are supporting the table, but laser filtering is a way to ignore that, and so it's not thought of as an obstacle. And there are various ways you can configure laser filters to exclude those extraneous solutions.
Alan,
The
did you have
Gopher
a
2 is on the Create 3 base, and that's interesting because there's a separate computer inside the Create 3 base that's running Ubuntu, and that's somewhat cool because as soon as you turn on the base, but it's also a little weird because you can't really configure that. You can only configure that in a very limited way. You can choose what network transport it has, and you have a choice of, uh, I think it's only running like a humble version of it there, and you can't update it in any way. And then there's a separate Raspberry Pi, this was a case of running on top, and that's what's talking to the cameras. One of the things I'm using a LD19, which is a really good LiDAR unit that I think is around $100, $115. Just plugs into the USB. Same thing with the Oak D Lite as the camera. And even, well, I don't know if the Oak D Lite now has an IMU in it, but that's okay because the Create 3 has an IMU in it if you want
Alan,
to.
did you have a video to show?
Yeah, I put it in the chat room. So if you want to click on that, if I try to do the video and display it, I won't be able to do it.
I'm having a little trouble getting over to that screen. So um,
Someone
it's in the,
someone in Mountain View
Stephen,
can click
Yep.
on it.
if you go to the very
Video.
top of the chat, there's the
Yes.
video. I think it's the first one.
First one at the top of the chat.
You mean from earlier? I may not have it.
Well, let
This
me
one?
send
Hold
it
on. Is it
again.
this one? No, that's mine that I posted.
Hold on. I'll put it in the chat again.
Now I have it. So hold on a second.
Yeah, that's it. I'm not hearing any sound though. Oh,
the base. So there's a little computer in the bottom of the vacuum cleaner that's running ROS. And then there's a Raspberry Pi 4 on top. We have a Oak D Lite, an LD19. It's using a plywood table, and I think it's 2020 extrusions. for the superstructure. So that's the physical robot. That's the rendering of it. URDF. You see the logo when you see that the camera is working. So I have a Logitech controller, and the benefit of the Logitech controller is that it has the dongle on the robot. So even if I lose network connectivity to the PC and I couldn't do teleop, I can do it. I can drive the robot with the joystick. You see. Running around. That's my butt. And you also notice that I'm using laser filtering, so you don't see any laser marks on the robot itself.
Yes, they regulate.
Here's your robot. Go back to where you came. And what's interesting, the bump is working on this guy. Yeah. So everything's fully functional.
Fully armed and functional.
Everything's fully functional except the operator.
Broken toe.
This was a really fun project, but as you can imagine, how long have I been working on this camp? About like a year
2.5 years. 2.5
What?
years. 2.5
2.5
years.
years.
Well, the funny thing is you get to a point. The funny thing is you get to a point where it's like you can still dot I's and cross T's. I could have spent another 2 weeks on it, but 2 weeks becomes 2 months, and 2 months becomes a year. So, anyways, let's get through this thing. Here's Ross's Turtletron, okay? And he's done a more siloed approach where he's making launch files that launch everything at once. Mine is more component where you launch the base, the LiDAR, the camera, you launch everything separately, but he's kind of put it all together. I think he's worked with Mike Wimble and Sergey on this, and his is the Turtletron, and here is his cheat sheet, if you will, telling how he's done it and how he's operating it.
We're not going to read it, are we?
Now here's Phil's CandyBot. CandyBot was built on a Create One. There's some Thomas. You want to talk about? I know your voice is gone, but you want to talk about Rosie? This is Thomas's robot, Rosie. And as you can see, it's got the tabletop on it and maps and navigates, and that's what we do. Okay. Moving on to chapter 7 now. This is LiDARs, cameras, and other sensors. LiDARs. We talk about the LD19 and the LD06. Now, in doing this, we're on a moving platform. I went back and tried to install DL06 on Jazzy, and it didn't work. Jazzy, it's got a problem with what was it? So I was trying to run the LiDAR on Jazzy, and it didn't run. It had a problem with Thread T. They don't use Thread T anymore, Ubuntu 24, like Humble did. And so I did some stuff in Chat GPT, and I got this running on Jazzy. Actually, my call's gone away again. It's Chat GPT, and the code didn't run. And I threw it in the Chat GPT, and it says, "Oh, we don't use Thread T anymore with Ubuntu 24. We use Thread. Would you like me to fix that for you?" And I says, "Yeah," and it fixed it for me. So I've got that down in tips and troubleshooting. So when you get into the LD06 or the LD19, hey, Alan, were you able to run the LD19 on Jazzy?
Yeah, I was doing it a long time ago, but I think I saw the thing with, I figured out how to fix
I couldn't
the
run it on Jazzy. I
red
had to
thing.
back. Oh, you know what? I take that back. I fixed it so that it does run on Jazzy, but you know it needed to be fixed because there's a change with threads between Humble and Jazzy. It changed. Okay.
Yeah, I remember vaguely there was an issue with that, but I fixed it without using AI.
Work smarter, not harder. Anyways, that's the DL06 and that's the LD06 and the LD19. Here's the RP LiDAR. One of the interesting things with the LP LiDAR is it did not include the base laser to base link transform. So I swiped the base link to base laser transform from the LD06 and pasted it into the RP one, the RP LiDAR. And of course it didn't work, but I pasted that into Chat GPT and it says, "Oh, would you like me to put the base laser to base link transform in there for you?" I said, "Yeah," and it fixed it. So that also is in. Actually, I think that's here. Um, okay, so here below, find a launch file that includes the base link to base link transform for the Mockbot order. This lets you map with the Create 3 or the Roomba by running Slam Toolbox. So this this code here for the IP, for the RP LiDAR, will include the base laser to base link transform. So again, you could just Velcro it to your base and run Slam Toolbox and map right out of the box. Patience is a virtue. Anyways, it's there. I'm going to go back to this. So that's the LD06 and the RP LiDAR, the Nito BotDAC LiDAR, the YD LiDAR. Laser filtering, this is what Alan was talking about. If you apply this when you're mapping, it'll filter out the chair leg. Cameras, we got the Oak D Light. Picam, Logitech camera. This is another key part of the project. Again, I think the big take homes from the project are the base laser transforms, this homebrewed ultrasonic sensor, and also the Mockbot Erdith. Those are the big deals. So here comes the homebrew ultrasonic sensor. Now, on this one, I found out that it too does not work on Jazzy, so I backed it up. My suggestion here is dedicate a Pi to it and put Humble on it. This tech talks about in the Raspberry Pi imager, you choose Ubuntu 2204 instead of 2404. And then install Humble instead of Jazzy. But here's the connection to the ultrasonic sensor. And there you do the ping, or you do the measurement with Python. And then we modified the simple publisher so that it becomes a range publisher. And this talks you through pasting that code in place of the hello simple text hello world, and so it becomes a range topic publisher. This is the code with the change. It shows the change. And again, we had to shorten it up to 1.4 meters instead of the 12 meters. This is the code for the navigation YAML. Okay, you got to plug that into the navigation YAML. Yet another markup language. Yeah, that's the homebrewed ultrasonic sensor. Here's a little bit about IMUs. Finally, navigation, putting it all together, okay? So first thing is mapping, okay? So I always start the teleop keyboard first. Let me let the screen catch up. Patience is a virtue. Okay, so this teleop keyboard, then you launch your base, whether you're running a Roomba or BotVac or the Create 3. You launch the base software, again, Create 3, you just switch it on and it's running ROS 2. Then you launch the, then I'm launching the LiDAR. Then you launch the camera. And then you launch the Mockbot Erdif. Then you launch Slam Toolbox and RViz, the visualizer. At which point you should get something like this. Patience is a virtue. There it is. So this is what you get when you run the Slam Toolbox and RViz, okay? You drive the robot around with your teleop keyboard and create a map like this, okay? My suggestion is as you drive around, make frequent saves, okay? So you map the room. Now you want to save your map. That's the 6-foot command there to save the map, okay? Let me let the screen catch up, sorry. There it is. So after you've saved your map, kill Slam Toolbox. Do not kill Slam Toolbox without saving your map, okay? Now we're going to navigate, okay? So you should have driven your robot around and created a map and saved that map with Slam Toolbox. Having completed the above, you should kill or quit RViz and Slam Toolbox. You can leave teleop keyboard, LiDAR, camera packages, and the Erdif running. I would exit RViz and refresh it. So now we're going to launch the sensor packages that were not used for mapping. Okay, that'll be used for navigating, for example, the ultrasonic sensor. Now we're going to launch the localization file. This launches the map server that loads in the map that you just saved. It loads in the AMCL, Adaptive Monte Carlo Localization, and also the life cycle. Now you want to launch the navigation stack. That gives you your global path planning, local path planning, and recovery behaviors. Finally, RViz. It'll come up something like this. Set your pose. Set the pose of your robot in the map. When you set your pose, it'll come up with the local cost maps and the global cost maps. Now you can click nav to goal and set your goal. Wherever you click on the robot on the map, wherever you click on the map, the robot will navigate there. If you've come this far, you've accomplished one of the central achievements in modern robotics, mapping and navigating. Not long ago, this work demanded a PhD and years of research. Today with ROS, it's within reach of anyone curious enough to try, sometimes with nothing more than a persistent and well-timed copy and paste. Patience is a virtue. It's coming. It's coming. So this is Smarty 3 navigating around the house. This is a physical robot navigating around the house. You see the Mockbot Erdif that went over a floor transition. You can see when it rocks, it hits the floor. This is regular Roomba, LD06 LiDAR, homebrewed ultrasonic ROS 2 sensor. Yeah. So here he's going to go to the end of the hallway. There's a hard floor transition here. You'll see him bump. See that? That's a bump.
Camp, can you wrap up in 5 minutes? That's already.
We're closing. I'm closing down now.
Do not leave your luggage unattended at any time. Do not transport any items.
Thank you, Kyung.
If someone has tampered with your luggage or if a stranger approaches you without carrying any object, contact the airline representative or the airport. All check and carry on luggage.
Basically, this is nav2 with waypoints. I set waypoints around the house, and he's navigating all the way around.
These are not bicycles, skateboard, hoverboard, and wheel footboard.
I'll advance it a bit there.
Or can determine.
This is tricky because he has to get through the narrow door, and there's a dog dish there. The door comes and goes, so he path plans around it. There he goes. That's Smarty 3 circumnavigating the house.
Person, passenger on flight 3057 service to San Luis Obispo. If you're traveling with car seats, strollers, any mobility devices, please be careful inside those items before boarding.
2-3 days now.
Looking forward, making robots more human, explore and lifelong mapping, GPS, fiducials, artificial intelligence. Thomas has got some good stuff here on AI with the mockbot. And then finally, tips and troubleshooting. And that's it. Questions? Did we have fun?
Yep.
All right. Thank you. All right. We're gonna start a mockbot SIG on Monday evenings at 7 p.m. So stay posted for that on the mailing list. Make a motion the meeting be adjourned. Do we have a second?
Yep.
All in favor, say aye.
Aye.
Those opposed, say nay. Ayes have it. Meeting adjourned. Thank you very much. We'll see you guys next month, if not before, okay?
Thank you so much.
Had fun.
Good luck here. Bye-bye.
Thank you. Andrew, good to
Bye.
see you.
Phil,
I got a plane to catch.
hey, Camp Phil just showed up. Camp Phil's here. Say hello to Phil.
Hey, Phil. We're so glad you can make it. Where's Phil? All
He's
right.
here.
Say something, Phil. Highlight him, Thomas.
Hello.
One of the
There he is.
mockers. How did you, did we have fun?
Yes.
Very good.
Yeah, I just let him in the door. I didn't see him until just seconds ago. He's ending
We'll
the
let
meeting early.
We'll let anybody in. Are you in Arizona now?
Yes.
All right. Are you fully moved?
Yes.
All right. Maybe you can show up for the mock SIGs on Monday evenings.
Same time, same.
We're going to do mockbot SIGs on 7 p.m. Monday evenings, kind of like the Ross discussion group and the AI SIG. 7 p.m. Pacific time.
7 p.m. on Monday?
Mondays. Thank you very much, everybody. I think we're done.
All right.
Yeah, I think you can stop the recording, Thomas, if you haven't already.
Yeah, the Camp's got to catch a plane there, Phil.
Oh, okay.
Yeah.
He's in
Yeah,
San
did you have something?
Diego.
Hey, Phil, did you want to say something specific about the project?
I wish I could have contributed more. When I started moving, my life fell apart. I'm sorry. It's been a.
Well, we got the Mockbot 6 coming up on Monday, so that'll be the
Okay.
thing to do. Thomas, take the